Good morning to all of you. Today I will discuss different types of instructions in 8085 microprocessor. What is instruction? Instruction, it is a binary pattern designed inside a microprocessor to perform a specific function. It's called instruction. This is your instruction. For example, move A comma B. It means transfer the contents of B into A register, and its hex code, it is 78H, and this is binary pattern 0111 and 1000. Okay, this is your binary pattern. What is the significance of this, and how will you find out this opcode? For this opcode of move is 01, and opcode of A, this is your destination register. Okay, this is destination. Its opcode is 111, and opcode of B is 000. So opcode will be 0111 and 1000. It means 78. Later on you will see how to determine opcode of any instruction. Okay, it means this is a binary pattern. What is the significance of this 01? 01 means move. Data is transferring from source to destination, and in this case destination operand is A. This A is your destination operand. Okay, so and source operand 000 B. So data is transferring from B to A. This is your hex code. Because in 8085 there are different types of instruction, and every instruction has one hex code, and this is called your opcode. And we cannot remember hex code of every instruction, so instead of this hex code we will use symbolic code like move A comma B. So this is nothing, this is mnemonic. This is a Greek word. It means mindful meaning. Mindful meaning means which you can remember in your mind. So you do not need to worry about this hex code. Just you should have knowledge of mnemonic. So what is a assembly language program? Assembly language program is nothing. It is group of mnemonics. And in 8085 there are 246 instructions, and each instruction is represented by an 8-bit binary value, and that is called your opcode. In move A comma B, move is opcode. What is the significance of opcode? Opcode means what operation has to perform. Means you are transferring data, or you are adding, or you are logically and applying, or you are complementing data. This move is nothing, this is opcode. This A and B, these are called operands, or you can say variable, and it means operation to be performed on is called your operands. These are the valid registers of 8085 microprocessor. What can be operand? Operand can be register, or it can be memory. And source operand can be either data or memory or register, but destination operand will always be either data or either memory or address, memory or registers. Now there are different types of instructions: data transfer instruction, arithmetical instruction, logical operation, branching instruction, control instruction, and in this we use different notifications. R means 8085 8-bit register. It can be A, B, C, D, E, H, L. M is memory register. This is very important. This M is indirect memory, whose address is specified by contents of HL register pair. Suppose H equal to 20, L equal to 50, then memory will be 2050, not 5020, because H is higher order register, so it will take higher byte 20. L is lower order register 50, so memory will be 2050. RS is source register, RD is destination register, RP is register pair, and It means contains of. Bracket means contains of. We frequently use these notifications in your different types of instruction. Now first of all, data transfer instruction. As the name indicates, data is transferring from source to destination. Okay, and these instructions move data between register or between memory and register. And you have to remember, both operands cannot be memory. One can be register, another can be register. One can be register, another can be memory. But both cannot be memory. These instructions copy data from source to destination. And one more thing you have to remember, the source data is not modified. Means data transfer instructions are nothing, these are copy instruction. Means source data will remain as it is. Only destination data will be modified. Now this is the very first instruction. Move RD, RS. This move, it is nothing. It means equal to, it is in C language assignment operator. RD, RS. RD is destination register. RS is source register. Contains of source register is transferred into destination register. Similarly, move M, RS. Contains of source register is transferred into memory location, whose address is specified by contains of HL register there. Similarly, move RD, M. Contains of a memory location whose address is specified by HL register pair is transferred into RD destination register. For example, move B, C. It means contains of C is transferred into B. Similarly, you can take move A, D. Contains of D is transferred into A. And one more thing you have to remember, size of both operands, means source operand as well as destination operand must be same. If one is of 8 bit, another will also be 8 bit. Now one more example, move B, M. Now you can say M is 16 bit, but contains of 16 bit address will be 8 bit. So it is valid instruction. Move B, M. Contains of a memory location M is transferred into B register. Okay, similarly you can take move M, E. It means contains of E is transferred to a memory location whose address is specified by HL register pair. Now next instruction. Now MVI RD, space data. Okay, you can take space here. What is the significance of this I? I means immediate data, means source operand is always data. In this, for this data, immediate data, we will use I. Transfer 8-bit immediate data to destination register. Similarly, MBI M data, move immediate data to memory, whose address is specified by HL register pair. Suppose example is MBI B space 57. Okay, replace this comma by space. B 57. It means what is the significance of this? It means B equal to 57. It means B equal to 57. B will be equal to 57. Means this immediate data is transferring into B register. Similarly, MBI M 57. It means M is 57. You have to remember, if there is I, it means immediate data. At last, if there is I, it means immediate data. Next, come into direct address. Suppose you want to apply any direct memory location as an operand, then you will use LD instruction. What is the significance of LD? LD means load. Load means data is coming in microprocessor. Microprocessor means part of microprocessor is register and default register is accumulator. So LD 2034, it means contains of this 2034 is transferred into A. Suppose contents of 2034 is 57, then what will be value of A? It will be 54. Suppose contents of 2034 is 54, then A will be 54. So this is your direct memory. In this you can transfer contents of that direct memory into accumulator, means accumulator is loaded. And one more thing you have to remember, in this case we can use only default register as accumulator. We cannot use B, C, D or other register. We LDB 16-bit address. This is invalid instruction. It only works for accumulator. And next instruction, LDAX B or D or H, register pair. LDAX register pair. The same thing. LDA means data is loading, data is coming in accumulator. Now what is the significance of this X? This X, it indicating there is 16-bit operation. Okay, means LDAX means data is coming in accumulator. Okay, suppose this is your instruction LDAX B, data of B, data of any memory location is coming in A. But what is that memory location? That memory location is indirectly specified by register pair. Okay, LDX B means suppose B equal 20, C equal to 50, then it will form a memory location, indirect memory 2050. Now suppose contents of 2050 is 25, then it is coming in A. It means A equal to 25. So you have to remember, when we use register pair in any instruction, we only mention higher order register. We do not mention lower order register. LDX BC, it is invalid. Only you have to remember, we only mention higher order register only, either B or D or H. Similarly, LDAX-D. What is the meaning of this? It means contents of a memory location whose address is specified by DE is coming into A. It is very simple. LD means load, A means data is coming, so X means 16-bit operation. LDX B. B, contents of B cannot be moved into A because we have already instruction move A comma B. Then X means register pair, so BC, and BC 16-bit and A is 8-bit. 16-bit data cannot be stored in A, so only last option is this BC is forming a memory location 2050 and contents of this is coming in A. Next, for 16-bit immediate data, L means load, X, again you have to understand, X means 16-bit operation, I means immediate data. So now you can say there can be 16-bit data as well as 16-bit address. If in last there is I, it means it is data. For example, LXIH space 2034, it means H means 20, L means 34. This 2034, this is not address actually, this is data. And you know contents of HL register pair is nothing, it is memory location. So M will be 2034. And for example, LXI B3050, you can also implement it MBI B30, MBI C50. It means B equal to 30, C equal to 50. Instead of using these two instructions, we will use LXI B3050 because it is one instruction and there are two instructions. Okay. So LXI means it is loading register pair with 16-bit data. There is immediate addressing mode. Later on you will see what are different types of addressing modes. Next, LHLD 16-bit address. Okay, what it will do? LD means it is loading, means data is coming in register. HL means register pair. So now the possibility is, suppose LHLD 2040 means data is coming in HL register pair. So This 2040 is not a data. Why? Because in last there is not I. It means it is address, and you know in one memory location only one byte is stored. So what it will do? It will transfer contents of 2040 into lower order register L and contents of 2041 into higher order register H. Again you have to remember it will work only for HL register pair. In case of register pair, default register pair in 8085 is always HL register pair. So LHLD 16-bit address means contents of that address is transferred into L and contents of address plus 1 means 2041 is transferred into H. Next instruction, STA 16-bit address. It is the reverse of LDA instruction. STA means store. It will store in any memory location which is specified in the instruction. STA 2050, it means contents of accumulator is transferred into memory 2500. This is, suppose this is your memory, this is direct memory. Contents of A is transferred into that memory location which is specified in the instruction. This is just the reverse of LDA 2050 or 2500. Next, STX register pair. Again, it is the reverse of LDAX register pair. Okay, what it will do? It will store contents of A into a memory location, and that memory location is specified by the contents of register pair. It is reverse of LDX register pair instruction. STXB. Suppose B equal to 30, suppose C equal to 50. Instead of, you can also use LXI B 3050. Now what it will do? It will transfer contents of A into 3050. Suppose contents of A is 45, MBI is 45, then contents of 3050 will be 45. Next, SHLD. This is the reverse of LHLD instruction. SHLD, it will store HL register pair directly. SHLD address, 16-bit address. It means contents of L is transferred into that given address, and contents of H is transferred into memory location address plus 1. Okay, suppose SLD 2550. It means contents of L is transferred into 2550 and contents of H means address plus 1, 2551 transfer into LHLD and SLD. Where you will use? When you have to access two consecutive bytes, when you have to perform 16-bit operation, then you will use LHLD and SHLD. SHLD to store the result in memory, to consecutive memory, and LHLD to load L and H from two consecutive memory locations. Next, XCHG. Again, this X has two meaning. One, XCHG means it will exchange. Then next X means it means there is 16-bit operation. XCHG, it exchanges contents of HL with D. Okay, means contents of H is transferred into D, contents of D is transferred into H. Similarly, contents of L is transferred into E, and contents of E is transferred into L. But how it is possible? Because you have only one data bus. When you are transferring contents of H into D, then contents of D will be overwrite. Okay, so in this case we use two temporary registers W and Z. Later on you will see in architecture of 8085 there are two temporary registers W and Z. In case of XCHG we use that two temporary register W and Z. Okay, again I am repeating, it exchanges contents of H with D. Why H with D? Because both are higher order register. L with E because both are lower order registers. Next, SPHL. Okay, this is stack related instruction. This instruction loads the contents of HL pair into SP. Contents of HL register pair into this. Suppose value of HL. Suppose value of HL LXIH. Suppose this is your instruction. So value of LXI space H 2050. It means H is 20 and L is 50. H is 20 and L is 50. When you will use this instruction SPHL, what will happen? Now value of SP will be what? 2050. So what is the function of this? It transfers contents of HL register pair into SP. So value of SP is 2050. So this is one way you can initialize stack pointer by using this SPHL. It will transfer contents of HL into SP. Okay. Next instruction we have XTHL. The contents of L register are exchanged with the location pointed out by the contents of the SP, and the contents of H register are exchanged with the contents of location SP plus, means top of stack. Okay, X means, here again two meaning. X means 2 byte, means register pair HL are using. Okay, and top of 2 byte, because we require 2 bytes. And later on you will see when we will discuss stack related instruction. PCHL, again it transfers contents of HL into PC. Suppose HL is 2050, then what will be PC? PC will be 2050. Value of PC will be, suppose value of suppose this is your, okay, this is, suppose this value H is 20 and F is 50. H is 20, sorry, this, when you will use PCHL, okay, PCHL, what will be value of PC? PC will be 2050. It means now program will execute from this 2050 memory location. You know what is program counter? It holds the address of next instruction which we have to fetch. So this PC will be 2050. It is nothing, it is equivalent to jump 2050. Later on you will see branching instruction. These two are equivalent to jump 2050, unconditional jump. Okay. Next instruction we have push register pair. It transfers contents of register pair into stack. Okay, in detail we will see in stack related operation. Push B means it will transfer contents of B and C register pair into stack, and stack pointer is decremented by 2. And similarly pop, it is the reverse of push. In this case 2 bytes from stack are retrieved, means suppose pop H, it means contents of 2 byte from stack is transferred into H and L register pair, and stack pointer is incremented by 2. Later on you will see in detail. Now last two data transfer instruction. Now you have to remember memory address is always of 16-bit in 8085, but there is input output port address. In input output port address, again you have to remember it is again 8-bit, not 16-bit. Input output port address is always 8-bit, ranging from 00 to FF. So you have to remember when there are only two instructions, in or out. In this case, this 78 is not a data. How will you identify? Out means in last there is not I, so it is sure this 70 is address. But you know input output port address is 8-bit. So out 78H. Out means data is going out from microprocessor and default register is A. So data will go from A to 78 port. Okay, suppose A equal to 45, then in 78 port value will be 45. Next, in instruction. It is reverse of out instruction. Again only accumulator is used. In 8C. Again this 8C is 8-bit input port address. So data is coming from 8C port address into A. This 8C is not data. This is input port address. So suppose contents of 8C is 25. Then value of A will be 25. Okay. These are all data transfer instructions. You will frequently use these instructions in assembly language program. And it is found that some students are not watching video lectures, so it will be very difficult to understand upcoming lectures and assembly language programming. So take it seriously. Okay. It's all about today lecture. In next lecture, I will discuss arithmetical and logical instruction. Thank you so much for watching.